Assalamualaikum warahmatullahi wabarakatuh. Good morning everybody. How are you today? My name is Rini Mutisari. Today we will learn the critical path method, a practical way to plan and control project. By the end, we will know how to find the critical path, the minimum project duration, and the slack for non-critical tasks. First, what GPM is and why we need it. Okay, what is GPM? GPM uses a network of activities and arrows to show the order of work. There are at least 4 advantages to using GPM. First, GPM shows dependencies, what must come first and what can run in parallel, so we can build a realistic schedule instead of guessing. Second, it reveals the critical path, which tells us the earliest possible finish date and exactly which tasks must not slip. That instantly guides priorities. If time is tight, we watch the critical tasks like a hawk. Third, GPM helps with resource planning. Once we know which tasks are critical and which have slacks, we can move people, equipment, or budget from non-critical work to the bottlenecks without hurting the finish date. The fourth, it supports risk management. By seeing where there's zero slack, we can pre-position buffers and backups or break down long critical tasks before they surprise us. Each box is an activity with a duration. An arrow means must come after. We read the network from left to right. The first node is the start, the last node is the finish. Some tasks must wait for others. Some can happen at the same time. Thus, at the same time, tasks are called concurrent activities. The concurrent activities, this is the project network for a home construction. We start at node 1, designing the house and securing funds, 3 units. Then we move to node 2, where the work splits, 2 to 3, making the foundation with 2 weeks, and 2 to 4 ordering and receiving materials. Notice the dummy are 3 to 4 with duration 0. This dot line is not real work. It enforces a precedence rule. Activities at node 4 can start only when both the foundation 3 and the material 2 to 4 are ready. From node 4, the work split again. 4 to 6 build the house with the 3 weeks, and 4 to 5 choosing point, followed by 5 to 6 choosing a carpet. All activities coverage at node 6 before the completion step 6 to 7. Using this network, we can run the forward and backward paces to find the critical path, compute the minimum project duration, and identify which tasks have slacks and which one must not be late. And concurrent activities. If 2 activities don't depend on each other, we can run them in parallel. Parallel work can save time, but the project still cannot finish sooner than the longest path from start to finish. That longest path is what GPM will find. So what is the critical path exactly? The critical path is the longest time road through the network. Its length equals the shortest possible project time. If any activity on this path is delayed, the whole project is delayed too. Activities not on this path have some free time called slack. To find it, we make 2 quick passes through the network. We do a forward pass to figure out how early each activity can start and finish, then a backward pass to figure out how late it can start and finish without moving the project in depth. The gap between latest and earliest is the slack. Let's walk the forward pass step by step. Start the clock at time 0. For each activity, its earliest start, or ES, is the largest earliest finish among its direct predecessors. Its earliest finish, or EF, is ES plus its duration. Move left to right until the end. The biggest EF at the final node is the earliest project completion time. Now we go backward to see how much flexibility we have. Okay, on this slide, we run the forward pass to find the earliest event time, or ET, at its node. The earliest moment that node can be reached if everything before it starts as soon as possible. We start at node 1 with ET equal to 0. activity 1 to 2 takes 3 weeks, so 82 equal to 0 plus 3 equal to 3 weeks. From node 2, we split 2 to 3 takes 2 weeks, so 83 is 5, and 2 to 4 takes 1 week, giving a candidate times 3 plus 1 equal to 4 at node 4. There is a dummy from 3 to 4 with duration 0. Node 4 can start only when both the materials 2 to 4 and the foundation 3 to 4 are ready. So we take the maximum of the arrivals, 84 is 5 weeks. As with the same method, the earliest time on the nodes are 81 is 0, 82 is 3, and 83 is 5, 84 is 5, 85 is 6, 86 is 8, 87 is 9. The key rule in the fourth batch is sum duration along each incoming path and take the maximum at each node, because our predecessors must be finished before that event can occur. Set the latest finish LF at the final node equal to the project time from the forward path, go right to left. For each activity, let us start LS equal to LF minus duration. For its predecessors, the LF is the smallest LS among their immediate successors. When you finish, every activity has a SAF, LS, and LF. With this 4 number, slack is easy. Now we do backward pass to find the latest event time, LT. The latest each node can occur without delaying the project. Start from the finish. The project time from the forward pass was 9, so LT7 is 9. Move 1 step back, activity 6 to 7 takes 1, so LT6 equal to 9 minus 1 equal to 8. Node 6 has 2 predecessors, 4 to 6 with duration 3 weeks, and 5 to 6 is 1 week. For 4 to 6, the latest start is x minus 3 equal to 5. For 5 and to 6, the latest start is x minus 1 equal to 7, so LT5 is 7. So with the same methods, the LTs are LT1 is 0, LT2 is 3, LT3 is 5, LT4 is 5, LT3 is 7, LT6 is 8, LT7 is 9. Notice that nodes on the critical paths have ET, LT, for example, 1, 2, 3, 4, 6, and 7. Well, node 5 has slacks, ET5 and LT5 6 versus LT5 7, meaning that branch can slip one time unit without affecting the finish state. Slack tells us how long an activity can be delayed without delaying the project. A simple rule, slacks equal to LS minus ES or LF minus AF. If slack is 0, the activity is critical. The chain of 0 slack activities is the critical path. That path length is the project duration. Now we use the LT and LT values to compute slack for its activity. Remember the rule, slacks equal to LT min AT, min T equal to LS min AS. If S is 0, the activity is critical. If S is larger than 0, it has that much free time before it will delay the projects. Let's read the network. So the slacks 1 to 2 is 0, so this is a critical, and 2 to 3 is also 0, so this is the critical 2, and 3 to 4 or dummy is 0, this is the critical 2, and 4 to 6, this is the critical 2 because the slack is 0, and 6 to 7, the slack is 0, so this is the critical 2. The remaining branches have positive slacks. 2 to 4, the slack is 1, 4 to 5, the slack is 1, and 5 to 6, the slack is 1. Activities with S equal to 0 from the critical path 1, 2, 3, 4, 6 until 7. Any delay here delays the entire project. activities on the set branch 2 to 4 to 5 and then 6 as time have one time units of flexibility. They can slip by up to 1 without changing the finish state. If we need to shorten the project, we must cross tasks on the critical path because only this will reduce the overall durations. Okay, this is the examples. Let's complete this project network using the critical path methods. Rate its activity on the networks A, B, C until E with the duration. A is 5 weeks, B is 6 weeks, etc. And not as activity immediate predecessors. Okay. The forward pass AS or EF start the project close at time 0 for every activities. AS earliest start the maximum AF of all predecessor. AF is earliest finish equal to AS plus duration example along path A, B, E, H, and E. For the larger AF, at the final node is the earliest possible project completion time. So this is the E. Yeah. Backward pass set the project LF at the finish node to the forward project duration 30 here. Move backward LS latest start equal to LF mean duration. For predecessor LF equal the minimum LS among all successor along A, B, E, H, and A. ALF equal to 30, LS is 30 minus 4 equal to 26, HLF equal to 20, and E equal to 11, and B equal to 5, and A equal to 0. And then we compute the slacks. Activities with 0 slack are critical. The chain of 0 slack activities from the critical path is total time equal the project duration from the forward path. The calculation gives the critical paths equal to A, B, E, H, and E with the total projection is, the total project duration is 30 weeks. What does this mean? Any delay on the critical activity delays the entire project's 1 for 1s. And non-critical activities have positive slack, so they can slip within their slack without affecting the finish state. And if we need to shorten the project, we should allocate resources or do crashing on the critical path activities because only they can reduce the total duration. So GPM tells us both the minimum completion time and which activity must be tightly controlled. Okay, ultimately, GPM empowers us to not just plan, but to execute project with precision and confidence. It has been vital in ensuring our project stays on schedule and within budget by prioritizing key tasks, which is critical for delivering results successfully and on time. Okay, thank you for your attention. Wassalamualaikum warahmatullahi wabarakatuh.